Okay.
It better be interesting.
There we go.
Let's go.
It's going to be the most interesting lesson that ever happened.
Oh.
Do you believe you mean that?
It is going to
Dead
pull,
people.
it is going to pull together multiple chapters in one, so hopefully it'll be
Okay.
satisfying.
It's like an ending to a story.
All right. So we've learned about different types of reactions. Today we need to talk about how to figure out the amount of the chemicals that you need for the reaction to happen, or the amount of chemicals that are produced when it happens. Okay? So for example, I want us to be able to answer a question like this. So let's say I had a certain amount of butane and I wanted to know how much oxygen do I need to go with it in order for it to actually react. Okay, so answering this kind of question is what we're trying to get at today. First thing you have to figure out is what type of reaction it is. So if I have butane and oxygen, what do you think we're doing?
Combustion.
Combustion. Yeah. So that's what we're getting into. Okay. Now, when we talk about how much, there's three kind of categories of units when we say the amount of something. So in the previous one, well, yeah, if I was asking like, how much oxygen do you need to react with this fuel? What are three different ways we could talk about the amount?
A little,
No.
a bit more,
Different.
and a lot.
No. What types of units?
Grams.
Grams, so mass is one. What are other ways we can talk about the amount of something?
Volume.
Liters.
Volume, okay.
Moles.
Kiloliters.
What?
Moles.
Moles.
Interesting.
Another one. Oh, I mean, yeah.
No.
Moles, and what's another one?
Particle.
Number of particles. Yeah, exactly. Okay. So these are ways that we talk about the amount of something, and we spent basically most of the last chapter converting between these. Yes.
Yeah.
Okay.
Okay.
So that's just a little reminder of what we're going to do. That. Okay. We're going to take this stuff from last chapter and apply it to this chapter. Okay. And then we use our conversion factors. Yes.
Yes.
Grams to moles uses molar mass. Moles to particles uses Avogadro's number.
Yes.
And then you go backwards, right? It's great. Picket fences, proportions, all that good stuff.
Like the best.
Okay. So, in order to convert between amounts of chemicals in a reaction, we're going to use mole ratios. So far, we've already talked about mole ratios, but we've talked about it in the context of an individual compound. Right? So in the past, we've talked about mole ratios in like, if I have 2.31 moles of this compound, I could figure out how many moles of each element there are in the compound.
Yeah.
Do you guys see how this math is working?
Yes.
Right? For every 1 mole of this, I have 3 moles of carbon.
Yeah.
So if I have this many moles of the compound, I have 3 times as many moles of carbon.
Yeah.
8 times as many moles for hydrogen and 2 times as many moles for oxygen. Right? So that's how we've done mole ratios in the past. Okay? But we can also use mole ratios within a chemical reaction. Okay? We can also apply mole ratios to chemical reactions. Okay? So if we're trying to answer this question, how many moles of oxygen do I need to react with 0.267 moles of butane? First thing I need is the reaction, the equation. Okay? You said it's combustion, right?
Yes.
There it is. Okay? Is it balanced?
Yeah. Oh.
How many carbons on each side?
No. Or yes. There's 8 on each side.
8 carbons?
Yep.
How many hydrogens on each side?
There are 20.
How many oxygens on each side?
There are 26.
26 oxygens on each side. Okay, so it's balanced.
Yeah.
Okay, good. Needs to be balanced or else this won't work. Okay, so notice what this is telling us. There's ratios implied in here. Notice how for every 2 molecules of butane, how many oxygen molecules do I need to react with it?
Wait, hold on. Can you read?
Everyone's giving me blank stares.
Yeah.
I have 2 of these, yes?
Yes.
In order for this reaction to work, I have to have 2 of these,
Yes.
and how many oxygens?
13.
26.
Oh,
How many
right.
molecules?
26.
How many molecules?
13.
13. Right there. 13.
Well, it says 13 and it's 13 sets of 2, so it'd be 26.
It'd be 26 atoms, but I'm asking about the molecules, right? For every 2 of these molecules, I need 13 of these in order for it to all combine and give me this. Yes?
Yes.
And these are the simplified ratios, right?
Yep.
So this is like the smallest amount that could make it work, right? If I only had 1 of those, it wouldn't work.
Yeah.
Because I would need 6.5 of these, and that's not a thing. So for every 2 of these, I need 13 of these. Yes?
Yes.
Okay. It's like for every 1 car, you need 4 tires.
Where is this number?
Unless you're one of those weird 3 car. 3 wheel.
A
We're not talking about that. Okay. So the coefficients are telling us something about ratios. For every 2 molecules of butane, I need 13 molecules of oxygen. We get that.
Yes.
Okay. Now, when we, as chemists, we don't really think in individual molecules necessarily, we think in moles. So I could take that ratio and just multiply it by a mole, right? So I could say for every 2 moles of butane molecules, I need 13 moles of oxygen molecules. Basically the same thing, right? Okay. So, this fact helps me answer this question. Right? Because, let me just make sure I stay on camera. For every 2 moles of butane, C4H10, I need 13 moles of oxygen, right? Wouldn't that mean that this ratio should be equal to this ratio? Where if I have 0.267 moles of butane, C4H10, I would need X moles of oxygen that is proportional in the same way that this is proportional? Does that seem reasonable?
Yeah. Yes.
Yeah. So the ratios are the same. Is this a proportion I can solve
Yeah.
and then figure out how much oxygen I need?
Yes.
Yeah.
Oh,
So-
that's what we're doing with it.
Yeah.
No.
Okay. But notice how the key here was this ratio. And notice how the ratio has moles over moles, which is why it's called a molar ratio, because it's moles over moles. Okay? And the important thing that I'm showing you is that these numbers came from the chemical equation. So there are ratios built in to those coefficients.
Can you cross multiply?
You can cross multiply, solve for x.
Cross multiplication.
Yep. Right, so you can do all that and solve it. Okay, here's another way you could solve it. Let me rearrange this and tell me if this is true.
Oh, I don't want. Do we need already a calculator? Okay.
What equation is that?
Yeah.
So all I did is I moved x over, and then I moved this fraction to this side,
Right.
so I have this. Did I solve for x correctly?
Perhaps, I don't know.
Yeah.
Okay. What does this look like?
This looks like the one thing and equal the right.
Bro, James is too excited for this.
The fences are cool.
Okay, so you can do it using a proportion, but you can also do it using a picket fence. Notice what's happening in our picket fence. I took my original amount, right? So the problem says I have this much butane,
Yes.
and I want to figure out how much oxygen. If I just multiply by the molar ratio given to me from the chemical equation, I get my answer. Yes.
Should that be 0.267?
Yes. Thank you.
Why do you do it that way instead of cross multiply?
There's gonna be an equation.
I do it this way because in about 5 minutes, this is going to be easier. For this particular problem, they are equally as easy, so I don't really care. But in a second, this is going to be easier. Picket fence always ends up being the easiest.
Yes.
And it's, if you just do everything picket fence, you don't have to keep track of all the different ways to do problems. But
Is there gonna be
It's
a
your life.
problem where it's like, oh, find the what is this? How many oxygen you need?
Oxygen atoms?
There are molecules to do the reaction, but we have to like find the like balance the equation, and then we have to take that, and jump through like a million.
Right, so in order to do this problem, also, you know if you hit B, it makes it black?
Oh,
That's
I did not know that.
quick thing,
That's
yeah,
actually
black.
useful.
If you hit W, it makes it white.
Oh,
What if you get blue?
Like just on
Wait,
a, like a regular Google
If you hit blue. That was good. Yeah,
that
anyway.
wasn't a joke, that was me being stupid.
I know. I mean, you're not stupid. It's fine. Okay. Yes. So I gave you the chemical equation,
yeah.
but we just learned about different reactions. So guess what I'm going to be able to expect you to do?
I didn't learn
Vito, can't
jack
stop.
from that.
You need to
I
be
did
able to
so
do.
bad on
Yeah.
functions.
We're bringing it all
Are
together.
you gonna give us like a 30-step problem on the final?
This is about as bad as it's going to get, and this is depends what you consider a step. It could be 2 steps. Write the equation, then solve the math problem.
Was that all?
That's
But that
That's
would
2 steps, right?
That would you
Each step is like
you
5
lying
different
to us.
things.
It's literally 2 steps.
That's like having like you have one homework problem with
First
24
step,
parts.
graduate from high school.
Yeah.
Right, exactly, yeah. I'm just chunking it together. Yeah.
To be a millionaire, first step, make $1 million.
Okay, so there we go. So that's me.
Doing stuff.
So there's the math. Okay, and I did the picket fence. Okay, and we did 3 sig figs. Great. Okay, let's try another one,
It's actually really easy.
and let's do it from scratch now. Okay.
Oh, wait,
I got 2.099 times 10 to the negative 3 moles of, what's this called?
nitrite. Or
We have to
nitrate.
use we have to use scientific notation and
ammonia.
This is ammonia,
What's ammonia?
That.
Ammonium?
ammonia, nitrogen, trihydride. Yes, it has 2 names. Okay.
Yeah, ammonia is better.
What am I trying to figure out?
How
What am I
many
trying
moles of hydrogen is
Mr.
the
Baby
result?
Yoda.
Oh, we're doing the opposite. Oh wait, no. No.
Similar idea.
Kind of the opposite.
The essential question is here, given an amount of this chemical, how much of the other chemical will there be?
Decomposition, so
It's decomposition, so that's a clue. Huh?
it'll be N plus H on the other side.
All right, so Will is decoding this. If we're decomposing, that means we're breaking it down into our elements.
So would it be n plus 3? Because it needs to be balanced.
Okay? Needs to be balanced.
Oh my gosh.
There's another thing we have to remember though. This is wrong.
Yeah, it's
This
been a
is
one.
already 3 steps, Mr. Floyd.
I mean, it could be a million steps if you count like breathe, reach your arm up, right down. So the number of steps is just.
Number of steps
One
is based on
more
different things.
Abstract concept to make it easier for other people.
Okay, what's wrong with my chemical equation right now?
Not a one
There's
in
no
front of
phases.
I don't know.
Phases could be important. They don't help us with this problem, so we're going to ignore them just because we can.
They
Charges.
That's a good.
by themselves.
Charges, meh. There are certain elements that are a little something I like to call diatomic.
Oh, like O2. Why is O2 needed?
N2 and H2.
Oh,
So you get
and-
like the 2 in front of the
Okay.
H3.
Nitrogen and hydrogen are diatomic.
Oh,
Whenever they are in their pure form, they are always in that form. And you have to know that. You have to catch that without me telling you.
The left side needs a
Wait,
2.
so we just lose a hydrogen? It's just-
I'm saying we have to have the right chemicals first, and then we can balance.
2 and H.
So now that we have the right chemicals, now we can balance.
So, yeah.
So 2 of these and 3 of these. Actually, it's still out of 3. That's funny. No. Yeah.
20.
Is it balanced now?
Yes.
Yeah.
Okay. So, just for everyone watching on the video, you have to get the chemicals right, then we can balance the equation. Okay? Yes, Thomas?
Could it also be balanced by splitting it into hydrogen nitride and hydrogen?
Yes. You could do that, but what we're going to do when we say decompose, we're going to assume that it goes to the elements. Yeah, to the pure elements. Otherwise, it's confusing on what could happen. So, another thing I do is I'll say completely decomposes. And so what I mean by that is all the way down to the elements. So we'll just assume that. Okay, great. I've got my equation. What are we trying to figure out?
The ratio right now.
Of what?
Remember, nitrogen,
Nope.
you need.
How many
a
moles?
Or ammonia, how many moles of hydrogen? Oh, wait a minute. How much hydrogen we need to get to?
Yes?
How much of the 2.099 is hydrogen?
No.
I was wrong.
Well, okay, kind of.
Backwards.
So I have this much ammonia
This could be.
present. Yes, I have that many moles. And when it decomposes, I want to know how much of this do I get,
Oh,
right?
big bits.
Picket fence.
I'm not understanding what we do from here.
Okay. We're just going to do a conversion.
How?
So the idea here is that for every 2 of these that decompose, I get 3 of those. We're going to use that ratio to figure out, well, what if I had this much ammonia?
Let's do it.
It's going to be a proportional amount. For every 2 of these, I get 3 of these. So for every this amount, I get a 3/2 amount of
Can we
hydrogen.
just do that number times 3 halves?
Yes.
Oh, okay.
Watch.
Uh,
Picket fence. So it's the same thing. Yes.
It's like a quiz game where it's like find the picket. Like where's Waldo?
Where's the picket fence? Yeah, there's always a picket fence in it. Okay, but yeah, what you said is essentially what the picket fence is. Notice how my units cancel out very nicely. So this is NH3, cancels with NH3, moles of NH3, right? Everything's moles, but it's moles of different things. So that's why I'm putting the chemical. So that times 3 divided by 2 gives me whatever my answer is.
Approximately 3.
Yes.
Or 3 times 10 to the negative 3. Calculator.
Bro got an expensive calculator?
Actually,
Bro stole it from Mr. Box.
I bought the batteries that are interesting.
Okay, so there we go. I don't know the answer, but whatever it is, it needs 4 sig figs, right? Okay, so I'll skip that.
3.000.
Something like that. Okay, last example. Last example of the entire school year.
Is there more things than this, or is it just bigger numbers? Is there another step? That smile scares you.
There is another step. You didn't think we were just going to keep this in moles, did you?
Bro, why would you do that?
That's what a villain would say.
Wait, we're gonna have to like use those on the table and then convert to grams?
Yes.
Bro, no.
Why did I switch this to grams? What am I trying
Because you're
to...
evil.
Well, besides that,
To add another
what does this
step.
have to do with the real world?
You didn't use
Because
grams
everything
more than
uses
moles?
grams.
Yeah, when I go to the lab and I measure out a chemical, I don't have a mole meter.
We should do that instead of grams.
We have a scale that weighs the mass.
We
In the-
have mole meters.
No. It's called your brain. Your brain is the mole meter. In the real world, we measure things in grams. So I need to be able to do this kind of
We
calculation
use pounds.
from grams. Well, same
way
thing.
better.
You
Right.
just divide by the molar mass, or multiply by the molar.
So here's what's going to happen. I'm going to have to go from grams of one thing to moles of that thing. Then I can go to moles of the other chemical and then grams of that chemical.
So 4 steps.
3.
5.
1.
7.
1.
Step number 1, write the balanced equation. Okay, what's reacting here?
Na of sodium hydroxide.
Sodium hydroxide and
Sodium hydroxide.
Grams.
Also sulfuric acid.
sulfuric acid is neutralizing.
What does neutralizing mean?
Great question. I was literally about to ask that. Why would I use that word here? What kind of reaction is this?
This is
Like
an
it's
acid
dissolving
base.
it?
That's going to turn to salt.
Acid, base, very acidic, very basic.
chloride.
They react, and it's neither acidic nor basic.
Salt water.
They cancel out. Salt water.
Question.
They cancel out. Yes.
For the final, are we going to be expected to have sulfuric acid and like other acids like memorized, or are we going to be provided with like H2SO4?
You memorize them.
Should we memorize the rules too?
What rules?
Should I just
The
drink
11 rules.
No.
sulfuric
So
acid?
we have to
Oh,
like,
we don't
memorize
have to?
sulfuric acid's H2SO4.
Mhm.
Or do all the acids follow a similar structure? Or
Yes.
What's the structure?
Polyatomic ion with H pluses.
All right.
So nitric acid
It's
is
just
nitrate.
so H2 and then
Well, nitrate is a -1.
oh so H and then NO3.
That's it. There's only 6 acids. was from the lesson on acids and bases. There's only 5 bases. So you're not memorizing that much.
I probably have a picture of this somewhere. Hold on.
Yeah.
It's on this slideshow.
I said you
It's
have
like
a bad
10 slides up or
memory.
something. Okay, what happens? Adrian knows.
It turns into salt water.
Okay, what do you mean by that? Spell it out for me.
Okay, so it's gonna be Na, Cl, and then, alright, there's no Cl.
There's no Cl.
NaSO4.
We're doing double displacement, right?
Yes.
It's acid base, but it's also double
And then
displacement.
H2O.
So NaSO4 plus H2O. I have a problem
It's
though.
not balanced.
It's not balanced.
Not only is it not balanced, I don't have the right chemicals.
What?
Before you balance the reaction, you need to balance your charges.
Oh.
Is this charge
Yes.
balanced? Probably not if I'm asking.
Oh, wait, you need 2 NAs and then you need.
Right, Na is a +1, this is a -2, so sodium sulfate is this. You gotta make the chemicals first and then we can balance the equation. Yes?
Would that be H3O? Since there's like 3
No.
H's?
Yes, but we don't, the 2 is here to balance the charges.
Okay.
So what we have here is H plus and OH minus.
Okay.
So we balance the charges first, so I only have 1 of each. But you're right, I have 3 H's and now I only have 2, so now we balance with the coefficients.
Okay. This is the culmination of like 5 different.
Yes, it is. It's brilliant.
Damn.
Okay, now that we have the correct chemicals, the correct chemical formulas, now we can balance the equation. Okay, speaking of endgame, let's end this part of the problem and balance it.
Yay.
Nice one, Mr. Boy.
Okay, do it, balance it, it's not balanced.
Oh, we have to do it?
Oh my gosh.
Okay, there's gonna be a 2.
There's a 2 somewhere.
The first,
Yeah, the first one has to be 2.
Need 2 sodiums.
the,
Oh, but now you need the 2 on the H2O.
Now I need 2 on the water.
yeah, and I think that's it.
No, pause.
Because now
I
there's.
think you need a 3 on the,
Yeah, we need a 3 on the H2O.
because we gotta balance.
We don't need a 3 on the H2O.
We gotta,
We need something
there's
on the
6.
SO.
How many H's right here?
6 oxygen.
2.
How many H's right here?
Wait,
2.
wait.
How many H's right here?
4.
Okay, H is balanced.
Interesting.
No,
Oh, there's.
H
O is
balance.
balanced, too.
O balances. The ends and meet. The A
No,
is
there's
balanced.
5.
It's all
oh,
balanced.
it's balanced.
It's
Oh,
balanced.
never mind.
Woo!
It's balanced.
What yeah, I was like, it's wait.
Good work, team.
Good work.
We did it.
Looked at a balanced
Yay.
equation for like.
Okay, so that was all step 1, right? Step 1, write the balanced equation.
No.
Step 2, solve the math problem now.
Oh, never mind. I thought you were.
I missed when we just stopped
admitting
at this
to
part.
there being more than 2 steps
Oh, no.
for a second.
Okay, so what are we trying to solve?
I forgot.
Yeah,
How
let's
many
read the
grams
problem.
of sulfuric acid?
So how much acid do I need in order to completely react with this many grams of my base?
That's a good question.
Let's do a picket fence.
Yes. Okay, so is it gonna be?
So let me blank the screen and kind of give us a roadmap.
Are we gonna need a periodic table for this part? This question?
Yeah.
or Google.
Okay, Google. Can we use
So,
Google on the
so
test?
okay,
on the test.
we're starting here, right? Grams of sodium hydroxide,
Okay,
and I want to get to grams of acid.
interesting.
My ratio is right here. It's a 2-to-1 ratio, yes?
Yeah.
Okay. Does that mean that if I have this many grams of base, I just have half as many grams of acid?
Yeah.
Would it?
Yes.
I'm asking you,
Is this
would it?
similar?
Because you haven't explained if it would or not.
Is this a gram ratio 2-to-1?
No.
Yes.
No, because they don't weigh the same.
Right, they don't weigh the
We
same.
have to find out.
It's a mole ratio. 2-to-1 is a mole ratio. This many moles, this many particles reacts with half as many particles, but it doesn't tell me about mass. So here's the kicker. This is going to be in all caps at the end of this slide. In order to go from compound to compound, you must go to moles first. I got to go to moles of sodium hydroxide, then I can go to moles of acid. Then I can go to grams of acid.
Oh, that's like 4 steps in its own.
1, 2, 3 steps.
That's like 3 steps all on its own.
Okay, but you gotta get that.
It's a 3-step, 2-step.
It is not 2 to 1 by mass. It's 2 to 1 by the number of particles. Okay,
So we only need to find the molar mass of the acid, right?
you need molar mass of both because going grams to moles is a molar mass,
Oh, right, yeah.
and then moles to grams is a molar mass.
Why can't we just keep them both as grams and then just compare it? Like if we found the grams that would weigh and we just compare those numbers.
Say that again.
Like if we use the periodic table to find how much grams the acid would weigh and then we just compare those 2 numbers.
But you also have to know the grams of this.
So we were told that.
Oh,
We were told how much of the grams.
well, okay. You would be getting the mass of 1 mole of this,
We only need 1 because it's 2 to 1, so we find.
but you don't have 2 moles of this. You have this many, whatever this many moles is.
Ah.
Yeah.
We would find that number and then divide it by 2.
Assuming you started with 2 moles of sodium hydroxide. This does not equal this.
So we don't
This is
need-
not 2 moles.
Interesting. It's 1.
No, it's 1.03 times 10 to the negative 2 grams.
So if we found the grams it's supposed to weigh as 1, we found that number.
You're
Yeah.
basically explaining
Okay.
you're basically explaining this in a really, but yes, the way you're thinking about it is basically correct. You're saying a lot of words that just equal picket fence.
Interesting.
Yes.
It always equals 50.
Right.
It always goes back to the picket fence.
Right, exactly.
I still don't know how to do this.
You can't keep getting.
Well, let's do it. Let's do it right now as practice. Okay. I was trying to think of an analogy of what you're saying. It's like you're trying to walk around and you always just end up coming back to the same spot. So.
Walking in a circle.
Okay. Where should we do it? How about down here? Okay. So picket fence. Write down what you're given,
Given.
and then usually I would do it with the chemical formula because that matters now. Okay. Step 1: grams to moles of sodium hydroxide. Okay. Molar mass. 1 mole of sodium hydroxide.
We can just say it's 1 mole.
Yeah, because that's what molar mass is, mass per mole. It has a mass of 39.997. Someone Google that.
9998.
So we would need to figure that out on our own. You just know off the top of your head. Okay.
I know this from, well, clearly. I know part of it from 4th hour. Grams of sodium hydroxide. Yes?
Yeah.
So to get that grams number, do we just find out what Na, O, and H and then add together?
Yep, that's what happened. Next step, now I can go from moles of sodium hydroxide to moles of acid. This is where my 2 to 1 ratio comes in. So now I want moles of acid. And I'm going to cancel moles of sodium hydroxide. Sorry, pardon my beautiful handwriting. This is a 1 to 2 ratio, yes? 1
Yeah.
to 2.
I got lost like 2 minutes ago.
Why?
So this ratio, 1 to 2, is from this.
So,
One,
so that matters now.
right, because we're doing moles now.
Okay.
So AKA, I have this weight of sodium hydroxide, which means it's this many particles.
Okay.
Now I know that for this many particles, I have half as many particles of this, right? Because for every 2 of these, you only have 1 of these.
Okay.
So that's the mole ratio.
So for every 1 over 39, we have 1 over 2.
Not really, no.
Okay.
No.
Big events is dumb.
If we did it in separate proportions, it would
I'm
maybe
gonna
make a
build
little
a
more
big
sense.
events when I get out of this class of bird.
Okay, so now this is gonna tell us how many moles of acid we have, how many particles of acid, molecules of acid. Now I wanna know how much it weighs. So we'll convert to grams. Grams of acid per mole of
So
acid.
we finally found what X is.
Well, I mean, this just equals X.
No. This is a nightmare.
It's almost done. What's the molar mass of sulfuric acid? Someone Google it.
98.086.
Thank you.
you should write out the math for this in like the longest, most like in-depth way.
I could show you a series of proportions. Because what this is this is a proportion, then that's a proportion, and that's a proportion.
Why do we have them all next to each other?
Because it's faster.
How?
Because I didn't have to do 3 separate equations, it's just one equation.
But how do I, like, if the picket fence wasn't there, how is this linear? Like, what is the purpose of it? How do I multiply through a picket fence?
Across the top.
These are fractions. I'm taking a number times a fraction times a fraction times a fraction.
So, is it literally just a number times 3 fractions?
Yes.
If I was writing on a
Yes.
calculator.
Yes.
Oh, that makes a lot more sense.
It's even easier than that, because when you multiply fractions, you just multiply numerators and divide by the multiplying of the denominator.
Oh, it took me till the end of my junior year to figure that out.
Yeah, me too, actually. I didn't know how to do fractions until like the beginning of this year.
It was like physical science, they were easy enough that I could
Oh
just
my
do
gosh.
it the other way.
Yes, A over B times C over D equals AC over BD.
And I'm trying.
That's what's.
I got there.
Can we do the answer now?
Yes.
What's the answer? How much acid do I need?
That's for Google.
Something.
Give the number up there.
I don't think I put the number on the slides. But that's the picket fence. Once you can solve that picket fence, there you go.
Okay, so we need, so you have what's given, so you have the grams given, and then you have the 1 mole over how much 1 mole of that weighs in grams.
Mhm.
And then you have the ratio of the 2 things together.
Yes.
And then you have how much that thing weighs over 1 mole.
Yes.
And then you multiply all of that.
Yep.
Please tell me there's only like one of these on the test.
1 or 2.
No.
Okay,
Two is
so
too
a
much.
common pattern you're going to see with these problems is grams to moles to moles to grams.
This
That's
one
kinda-
problem is gonna take 15 minutes to do on the test.
What's the 98.8086 or is
That's
that?
a 6, yes.
Okay, that's what I thought. I just-
Obviously.
Well, yeah, it
No,
is
I'm
like a
kidding.
6.
I'm kidding.
But like, there.
And if you're going to put multiplies between these two numbers, then you need to have parentheses on the bottom.
Oh.
Okay. Otherwise, I just do this times this divided by this divided by this.
So divided by in parentheses.
Yes.
39.
Times 2.
Why can't you just multiply 39 times 2 and just have the number on its own?
You could also do that.
Okay.
That's another step though, Ethan. I don't really like that.
Aha!
No idea what you tried.
What's the number you got?
What'd you get?
0.0122.
Yes, that's right.
Okay.
Oh boy. People do this for fun?
No, they do this for their job.
Yeah.
No.
This,
I would love to get paid for this stuff. If I have to go through all of this, I better be getting paid.
They just know-
They get
Can
paid like
you do
6
it?
figures.
this is people's job. Okay, so what was the answer? 0.0122 4 sig figs?
If you did this for your job though, it would get so easy.
Yeah.
That's true. But
Yeah,
like,
this is, yeah.
How
How do you
much
think
do
I
you-
feel about this?
how much you get paid? Like the average person is for a living.
This, no, you don't get paid to calculate stuff.
Why not?
You get paid to solve problems or do things, and then you just calculate stuff as part of that.
What if I want to be the calculator guy? I just ask professionals to do it.
They
Get paid,
would be
$1
like,
million
you're
a year."
fired, ChatGPT can do this.
No.
Fourth sig fig, I need a fourth sig fig.
Why are we learning it, ChatGPT?
2.
0.
I don't know.
I'm just guessing.
Oh,
It's
yeah,
on
sorry.
your calculator.
0.012297593.
So it would be 30.
I
That
don't
was
know
so much
about
fun.
that.
I didn't- at least I didn't clear
That
it.
took us 15 minutes.
Well, we did a lot of talking, so.
And the answer is 1, 2, 3 in it. That sounds so staged.
It's 1, 2, 3.
It's not 1, 2, 3, it's 0, 1, 2, 3.
It's the same.
It's worse.
It's
worse.
Okay,
Yeah.
questions.
Easiest one.
That is a lie.
Questions. Should I do another example?
no.
Question: Why
I
do you
said
make high
probably
schoolers
should.
go through this?
How different is it from this?
It's the same.
What if we're given?
Oh, no, literally, I have 2 more examples, and it's literally the same. It's a mole one and a gram one.
Okay.
Wait,
So they're the examples are not different.
I would love a mole one
Can you
with those
just-
rings.
Okay.
Can you just real quick, in like 5 words, just describe the conversions that happen in order? Like what you find out and
Man, I can tell this thing.
So
Just
if
generally.
I give you grams and I want you to give me grams, it's grams to moles to moles to grams.
You did it in 4.
4 steps, right?
What is that?
In stirrups.
Yeah.
People
Okay.
were throwing that back.
Are
and
we
forth.
doing a mole example?
If you want to.
Doing a mole example? Okay, here we go. How many moles of glucose are produced when 0.115 moles of water reacts with excess carbon dioxide?
This is one of those sticky step problems.
0.0534.
Combustion.
This is a
right?
one-step problem.
It's one.
This is
Combustion,
not.
right?
Nope.
So this
Water and
is-
CO2.
Water and CO2 make sugar.
Oh.
They do.
Kind of, not really.
So you-
Synthesis. Water
Oh,
reacts with
yeah.
carbon dioxide, yes?
Yes.
Synthesis is organic combustion.
It is basically combustion backwards.
See, so I had a right to be confused, so nobody left.
This is harder than geometry, bro.
Yeah, this is harder than any math class I've
This is
seen.
the hardest class a lot of people take in high school.
Yeah.
Let's take Calc 1 or physics.
I'm taking Calc 1. No, Calc 1's harder than this.
Oh, Calc 1 is the hardest class in this school, I think.
Is statistics easier or harder?
Easier.
No.
Are we doing this or not?
Yes.
No.
Balance it.
Like 3,
Please.
5, 2. I just guessed.
You're wrong.
You put 6.
Thank you.
Was the
6.
first one you
Again.
6 also?
And it's balanced.
No, it's not. Wait, we need.
No.
Wait, do we need a 2 over there?
Bro, Dan's gonna be so sad if he missed this class.
Oh, yeah.
I feel bad for people that missed
this
Yeah.
class.
We need to change the first one again.
Bro, it's hieroglyphics. We're getting
To 12.
We're getting the full lesson.
Because now hydrogen is balanced.
Rather than train.
And oh my gosh. And
Yeah.
but that unbalances the C.
So you can see it.
So now we would need 12 there. But then that
This.
no that wait, that's
Wait a
balanced.
second.
That's balanced now, right?
No.
Wouldn't it
No.
do
Because
6,
if
6,
it's
1?
12, 12, 2, that would mean it had to be a 6, 6, 1. But that's
Not the case.
17.
Something's off.
661 works. This is, yeah.
Oh,
Oh. Will's numbers are too big.
hey. I don't know.
Which one's the worksheet?
We all ignored the question you did on your
Is
own.
it this?
We just like looked at it and immediately see like, wait.
Is it balanced?
Yeah.
Is it?
Yes.
It's balanced.
He said it was, so I
Yeah,
hope
I knew it.
so.
I was right from the get.
Okay, so I have this many moles of water.
But there's not enough oxygens on the right side.
Yes, sir.
Not enough
Oh,
space.
there's not. Yeah, you're right.
See, that's why I was like looking at it.
I wasn't right from the get-go. I was lying.
Because there's 12 and 6, which is 8.
Yeah.
Am I doing that?
Yeah.
There's 18.
So there'd have to be 3 on the other side.
Yeah.
Okay,
Which
one,
would make
two
everything
questions.
go up.
Don't you just add?
One, you're missing a pass too.
Oh.
Why can't I balance this? What's
Will did it
Oxygen
balance.
thing.
Hey, you know what I did do though? I got
You make glucose and oxygen, right? Not just glucose.
Oh. Is that what's happening?
Yeah.
What is the glucose reduced? Yes. Oh, yeah.
Okay.
Thank
So we were almost gonna like.
Yeah, this video is way longer than it needs to be. Here, we'll
This
just
is
use
a
the answers right there.
packed video.
Thank
People are
you,
gonna-
Thomas.
This is active.
Thank you, Thomas.
Thomas is a hero.
You run so many ads on this.
Yeah. People would like laugh at it too because we're like goofy.
True.
Okay, it's balanced. We did it.
Yeah.
Okay. I have this much water.
That's a lot of water.
What am I trying to figure out?
How many moles of glucose are produced when 0.155 moles of water reacts with?
Notice I'm already in moles,
What do you mean excess?
and it's asking for me to
How are
moles.
we gonna find out how many CO2 there are?
So what's my ratio of water to sugar?
6 to 1.
6 to 1. Yes?
Yes.
Because 6 moles of water for for every 1 mole of sugar. I love how Ethan asked for this example and then left. Divide by 6, that's your answer, right?
I will stay.
No. Wait, yeah, is it?
Yes.
You need- Yeah.
That's it.
0.115 divided by 6 is equivalent to, oh my gosh.
Everybody left without the worksheet.
6.66667.
I'll probably pick up a worksheet.
Oh yeah, do we have a worksheet?
Yep.
Yeah.
It's also a work day tomorrow.
Okay, so I'll just get.
Okay, there we go. Thanks for watching, everyone.